IgE cross-linkage initiates degranulation. The biochemical events that mediate degranulation of mast cells and blood basophils have many features in common. For simplicity, this section presents a general overview of mast cell degranulation mechanisms without calling attention to the slight differences between mast cell and basophils. Although mast cell degranulation generally is initiated by allergen cross-linkage of bound IgE, a number of other stimuli can also initiate the process, including the anaphylatoxins C3A, C4A, and C5A, and various drugs. This section focuses on the biochemical events that follow allergen cross-linkage of bound IgE. Receptor cross-linkage. IgE-mediated degranulation begins when an allergen cross-links IgE that is bound or fixed to the Fc receptor on the surface of a mast cell or basophil. In itself, the binding of IgE to Fc epsilon R1 apparently has no effect on a target cell. It is only after allergen cross-links the fixed IgE receptor complex that degranulation proceeds. The importance of cross-linkage is indicated by the inability of monovalent allergens, which cannot cross-link the fixed IgE to trigger degranulation. The importance of cross-linkage is indicated by the inability of monovalent allergens which cannot cross-link the fixed IgE to trigger degranulation. Experiments have revealed that the essential steps in degranulation is cross-linkage of two or more Fc epsilon Ri molecules with or without bound Ig. Once again, experiments have revealed that the essential step in degranulation is cross-linkage of two or more Fc epsilon R1 molecules with or without bound Ig. Although cross-linkage is normally affected by the interaction of fixed IgE with divalent or multivalent allergen, it also can be affected by a variety of experimental means that bypass the need for allergen and in some cases even for IgE. Intracellular events also regulate mast cell degranulation. Intracellular events also regulate mast cell degranulation. The cytoplasmic domains of the beta and gamma chains of Fc epsilon R1 are associated with protein tyrosine kinase (PTKs). So, cross-linkage of the Fc epsilon R1 receptors activates the associated PTKs, resulting in phosphorylation of tyrosines within the ITAMs of the gamma subunit, as well as phosphorylation of residues on the beta subunit and on phospholipase C. These phosphorylation events induce the production of a number of second messengers that mediate the process of degranulation. Once again, I'm going to read this because I don't understand. So, intracellular events also regulate mast cell degranulation. The cytoplasmic domains of the beta and gamma chains of Fc epsilon R1 are associated with protein tyrosine kinase (PTKs). Cross-linkage of the Fc epsilon R1 receptors activate the associated PTKs, resulting in the phosphorylation of tyrosines within the ITAMs of the gamma subunit, as well as phosphorylation of residues on the beta subunit and on phospholipase C. These phosphorylation events induce the production of a number of second messengers that mediate the process of degranulation. Within 15 seconds after cross-linkage of Fc epsilon R1, methylation of various membrane phospholipids is observed, resulting in an increase in membrane fluidity and the formation of Ca2 plus channels. An increase of Ca2 plus reaches a peak within 2 minutes of Fc epsilon phospholipids is observed, resulting in an increase in membrane fluidity and the formation of Ca2 plus channels. An increase of Ca2 plus reaches a peak within 2 minutes of Fc epsilon R1 crosslinks. This increase is due to both the intake of extracellular Ca2 plus and to a release of Ca2 plus from some sort of allergen cross-linkage of cell-bound IgE. Then antibody cross-linkage of IgE. First one was allergen cross-linkage of cell-bound IgE. Antibody cross-linkage of IgE. Antibody cross-linkage of IgE. Then chemical cross linkage of IgE, enhanced Ca2 plus influx by ionophore that increases membrane permeability to Ca2 plus. Trigger degranulation of mast cells. Intracellular stores in the endoplasmic reticulum. The Ca2 plus increase eventually leads to the formation of arachidonic acid. Arachidonic acid, which is converted into two classes of potent mediators, prostaglandins and leukotrienes. The increase of Ca2 plus also promotes the assembly of microtubules and the contraction of microfilaments, both of which are necessary for the movement of granules to the plasma membrane. The importance of a Ca2 plus increase in mast cell degranulation is highlighted by the use of drugs such as disodium chromoglycate, chromolyin sodium. Wait a minute. Intracellular stores in endoplasmic reticulum. The Ca2 plus increase eventually leads to the formation of arachidonic acid, which is converted into two classes of potent mediators, prostaglandins and leukotrienes. The increase of Ca2 plus also promotes the assembly of microtubules and the contraction of microfilaments, both of which are necessary for the movement of granules to the plasma membrane. The importance of the Ca2 plus increase in mast cell degranulation is highlighted by the use of drugs such as disodium chromoglycate that blocks this influx as a treatment for allergies. Concomitant with phospholipid methylation and Ca2 plus increase, there is a transient increase in the activity of membrane-bound adenylate cyclase with a rapid peak of its reaction product, cyclic adenosine monophosphate, reached about 1 minute after cross-linkage of Fc epsilon R1. The effects of CAMP are exerted through the activation of CAMP-dependent endoplasmic reticulum. Protein kinase, which phosphorylates proteins on the granule membrane, thereby changing the permeability of the granules to water and Ca2 plus. The consequent swelling of the granules facilitates their fusion with the plasma membrane, releasing their contents. The increase in CAMP is transient and is followed by a drop in CAMP to levels below baseline. This drop in CAMP appears to be necessary for degranulation to proceed. When CAMP levels are increased by certain drugs, the degranulation process is blocked. Several of these drugs are given to treat allergic disorders and are considered later in this section. So, several pharmacologic agents mediate type 1 reactions.